Okay, we're going to go through an example of stationing, which is a common way of representing or measuring distance along a linear feature in a set of plans or in the horizontal plane. Basically, it is you would station a roadway, a sidewalk, a pipe network, a river, culvert, anything that is a linear feature. And basically a station is simply the distance that a point is from the beginning, the station 0 plus 0, 0, which is defined basically by the person developing the plans. So what you see here is a simple center line for a sidewalk. And this is for a sample problem we'll do where A, B, C, D, and E are locations of lampposts. And we're just going to station along this sidewalk so that we know exactly where the lampposts are located. So I know here from the figure that station C is 12 plus 0, 7. And again, stations come from chains from back in the old days, basically, where you had 100-foot chains and you would measure the distance in chains from one point to another. So station 12 is 1,200 feet plus 7. So it's always the number of hundreds of feet first, and then anything less than 100 feet is the second after the plus symbol. So station 12 plus 0, 7 is 1,207 feet from station 0. Okay, so what we're going to do now is work through a sample problem, and just to help better illustrate stationing and introduce a little bit the concepts of slope distance and vertical angles. So the problem statement here is you've been asked to conduct a quick survey to determine stations for lampposts, as I said before, at locations A, B, D, and E. We know station C. We are given a 300-foot tape measure and what's called an electronic theodolite. For now, don't worry about too much what that is. Basically, it lets you measure the angle between 2 points from the horizon or from a horizontal line. So in other words, it measures the vertical angle. If it's positive, you're pointing up from one point to the other. If it's negative, you're pointing down. In other words, a negative slope. And I'm going to use these two instruments to derive the horizontal distance, because stations are the horizontal distance between points on a linear feature. There is no elevation z component whatsoever in a station. So this is what we know. We go down here to the data we're given that was collected in the field. We know that standing at station C, if we take a measurement back to station B, we know that's 216.33 feet slope distance. In other words, there is some slope in that measurement. And the vertical angle between C and B is negative 2 degrees, 54 minutes, 43 seconds. So I'm going downhill from C to B. Alright, so first thing we want to do is let's estimate the location of station B or A or any of the stations. So let's look at this example here. And let's just start with C to A. So what I like to always do is make sure I draw a sketch of anything I'm doing, because that helps me be sure I've got all my components together. So here I am standing at station C, looking back to station A, but I'm in profile view. So distance along the x-axis now is a distance along that linear feature in the horizontal plane. Distance in the y direction is my elevation change. So in this case, I know that I have a 1 degree, 38 minute, 28 second positive vertical angle from C to A, so I'm going uphill, and I have a 274.21 feet slope distance. Now, in order to determine the station at A, I want to know the distance right here, my horizontal distance. So all I'm going to do is use trig to drop this slope distance down to the horizon. And that's what I've done here. My distance from A to C in the horizontal plane is 274.21 feet times the cosine of this angle. And I mentioned in class how you derive decimal degrees from degrees, minutes, seconds. You certainly use a calculator or a spreadsheet if you want to do it the old-fashioned way. This is simply 1 plus 38 divided by 60 minutes plus 21 divided by 3,600 seconds. And again, there's 3,600 seconds in an hour. So it's a 1.639 degree decimal degree angle. And you see here my horizontal distance is 274.1. Now, therefore, station A, if I come back up here and look at this figure, one thing I did not mention a moment ago, my stationing, I've been told, is increasing as I go from west to east. That's something you have to be told. So therefore my station at A will be less than the station at C. So I want to subtract this horizontal distance from the station to determine an estimate of the station at A. So I will take 12 plus 0.7, subtract 274.1, and you see here I've just converted to regular feet, and that ends up being a distance of 932.9 feet. So 9 hundredths plus 32.9. So station A estimated is at 9 plus 32.9. And I do all my other stations exactly the same. Now I want to mention a couple of things really quickly. B, why are the stations in Part A estimates? What I just showed you was I measured the distance from C to A in a direct path. Stationing is actually the measurement along the curved linear feature. So therefore, this is going to be a little bit short of what my actual distance is going to be here. Is that an issue? It depends on your application. But in this case, it is important to note that I did not measure the actual horizontal distance along the feature. I just took a straight shot from C to A. So that's the reason why they're estimates. Part C, why was it important that you were told the heights above the ground of the tape and the theodolite target are why was I told these heights? Well, if you look up here, I was told that the tape is held 4 feet above the ground at each point. Therefore, the location of the tape really doesn't make a difference in terms of the slope distance. I'm exactly the same height above the ground. Same with theodolite. If there's a difference between the actual instrument and the target, and again the target's usually a prism you're shooting energy off of, then I have to take that into account because that's going to distort my angle a bit. But in this case, since they're kept constant, that's just fine. So we'll talk much more about this when we get into working with total stations later. Okay, so and I will leave it to you to think a bit about systematic error and random error in this survey. Actually, D, E, and F are all things that are important to think about. We can talk about in class a bit, but again, I wanted to give you a basic idea of what stationing was and an idea of how to calculate that. So if you have other questions, please email me, or I'll see you in office hours. Thank you very much.